Hello students, welcome to your channel. Please like, share and subscribe my own channel, School Studies. School Studies is pleased to announce the launch of our educational website, Patel Section. After years of hard work and dedication, we are delighted to officially announce the launch. Today we will see a video related to NCERT solution for class 9 Mathematics chapter 5 Introduction to Euclid's Geometry. Exercise 5.1. First question of the textbook is, which of the following statements are true and which are false? Give reason for your answer. Only one line can pass through a single point. False. There can be infinite number of lines that can be drawn through a single point. Hence the statement mentioned is false. Next, there are infinite number of lines which can pass through two distinct points. False. Through two distinct points, there can be only one line that can be drawn. Hence, the statement mentioned is false. A terminated line can be produced indefinitely on both the sides. True. A line that is terminated can be indefinitely produced on both sides, as line can be extended on both its sides infinitely. Hence, the statement mentioned is true. If two circles are equal, then their radius are equal. True. The radii of two circles are equal when the two circles are equal. The circumference and the center of both the circles coincide, and thus the radius of two circles should be equal. Hence, the statement mentioned is true. In figure 5.9, if AB equals to PQ and PQ equals to XY, then AB equals to XY. Yes, it is true. According to the Euclid's first axiom, things which are equal to the same thing are also equal to one another. Hence, the statement mentioned is true. Second question, give a definition for each of the following terms. Are there other terms that need to be defined first? What are they and how might you define them? First one is parallel lines. Second is perpendicular line. Third, line segment, radius of a circle, square. Yes, there are other terms which need to be defined first. They are plane. Flat surface in which geometry figures can be drawn are known as plane. A plane surface is a surface which lies evenly with the straight lines on itself. Point. A dimensionless dot which is drawn on the plane surface is known as point. A point is that which has no part. Next is line. A collection of points that has only length and no breadth is known as a line, and it can be extended on both directions. A line is breadthless length. Now, the parallel lines. Parallel lines are those lines which never intersect each other and are always at a constant distance perpendicular to each other. Parallel lines can be two or more lines. Next, perpendicular lines. Perpendicular lines are those lines which intersect each other in a plane at right angles. Then the lines are said to be perpendicular to each other. Line segment. When a line cannot be extended any further because of its two end points, then the line is known as line segment. Line segment has two end points. Radius of a circle. A radius of a circle is the line from any point on the circumference of a circle to the center of the circle. Next, square. A quadrilateral in which all the four sides are said to be equal and each of its internal angle is 90 degree, or we can say right angles, is called square. Third question. Consider two postulates given below. Given any two distinct points A and B, there exists a third point C which is in between A and B. Next, there exist at least 3 points that are not on the same line. Do these postulates contain any undefined terms? Are these postulates consistent Do they follow from Euclid's postulates? Explain. Yes, this postulate contains undefined terms. Undefined terms in the postulates are there are many points that lie in a plane. But in a postulates given here, the position of the point C is not given, as of whether it lies on the line segment joining AB or not. On the top of that, there is no information about whether the points are in same plane or not. And yes, these postulates are consistent when we deal with these two situations. Point C is lying on the line segment AB in between A and B. Point C does not lie on the line segment AB. No, they do not follow any Euclid's postulates. They follow the axiom. Next, if the point C lies between 2 points A and B such that AC equals to AB, then prove that AC equals to half AB. Explain by drawing the figure. Given that AC equals to BC, now adding AC both sides, LHS plus AC equals to RHS plus AC, that is AC plus AC equals to BC plus AC. So this will become 2AC equals to BC plus AC. We know that BC plus AC is AB as it coincides with line segment AB. So 2AC equals to AB. If equals are added to equals, then the wholes are equal. So AC equals to half AB. Next, in question 4, point C is called a midpoint of line segment AB. Prove that every line segment has only one midpoint. So let AB be the line segment. Assume that point P and Q are the two different midpoints of AB. Now, their P and Q are midpoints of AB. Therefore, AP equals to PB and AQ equals to QB. Also, PB plus AP equals to AB. Similarly, QB plus AQ equals to AB. Now, adding AP to the LHS and RHS of the equation, AP equals to PB. We get AP plus AP equals to PB plus AP. So 2AP equals to AP. Similarly, 2AQ equals to AP. From 1 and 2, since RHS are same, we evaluate the LHS. So 2AP equals to 2AQ. So 2 will cut. Things which are equal to same thing are equal to one another. So 2 will cut. So AP equals to AQ. Things which are double of the same thing are equal to one another. Thus, we conclude that P and Q are the same points. This contradicts our assumption that P and Q are two different midpoints of AB. Thus, it is proved that every line segment has only one and only one midpoint. Hence, it is proved. Next, in figure 5.10, if AC equals to BD, then prove that AB equals to CD. It is given AC equals to BD. From the given figure, we get AC equals to AB plus BC. AD equals to BC plus CD. AB plus BC equals to BC plus CD. So AC equals to BD given. We know that according to Euclid's axiom, when equals are subtracted from equals, remainders are also equal. Subtracting BC from the LHS and RHS of the equation AB plus BC equals to BC plus CD, we get AB plus BC minus BC equals to BC plus CD minus BC. So AB equals to CD. Hence it is proved. 7th, why is axiom 5 in the list of Euclid's axiom considered a universal truth? Note that the equation is not about the fifth postulate. Axiom 5, the whole is always greater than the part. For example, a cake. When it is whole or a complete, assume that it measures 2 pounds, but when a part from it is taken out and measured, its weights will be smaller than the previous measurement. So the fifth axiom of Euclid's is true for all the materials in the universe. Hence, axiom 5 in the list of Euclid's axioms is considered a universal truth. So this was exercise 5.1 of NCERT solution for class 9th mathematics. I hope you like my video. Thanks for watching my video. Thank you. Please leave comment, question or doubts in comment section if you have any, or you can drop a mail to us. You will find my email ID at the end of this video. You can also join us on Facebook page, follow us on Instagram, connect us on LinkedIn or tweet us on Twitter. Thanks for watching my video. Thank you.